Hey guys, so welcome to another pre-AP lab. This one will be for isotopic pennies. What I'm going to do in this first little bit is do a couple of weighted average calculations for you as an example or examples, and then turn you loose to do the rest of the lab. And there'll be a couple little videos and some data that you'll have to take down in order to solve and then submit at the end. So let's go ahead and get started. See if I can manage this. All right. Okay. So let's do two weighted average calculations as demonstrations. So your academic achievement, this one should not be true, but it may be. Your academic achievement average, let's say, is a 62, and your academic practice average is a 91. The assessment or academic achievement averages are weighted 75%, and the practice grades are weighted 25%. So what is your overall average in chemistry? Many of you can already do these. This is not difficult, but it may be good to see an example of it just in case. All right, so so we know that the academic average, or your academic achievement, average is 62, and the percentage of that was 0.75 or 75%. All right. Added to that is going to be your academic practice average, which in this case was much better. It's a 91, and your percentage or the percent weight of this is 25%. So you use this to calculate what your overall average is. You would, of course, have to average all of your academic achievement grades based on their weight, number of times to get at 62, and the same with your practice of 91. But anyway, if I multiply these out, this one ends up being 47. This ends up at 23, and so your overall average would be a 70. Even though you're failing all your tests, you're still passing the class. 70 is not really what we're hoping for, but you kind of get the idea, especially with a 91. You're carrying yourself with your homework, so make sure you do your homework. Let's do a real calculation with actual isotopes instead. Better example. So here, calculate the percent abundance of each of two isotopes of an element that has an average atomic mass of 35.453 AMUs, atomic mass units, and the mass of the individual isotopes, so that was our average, the individual isotopes are 34.969 and 36.966. This is done a little bit differently. So you have two different isotopes. You have this first one, which we'll call X, and you have this other one that we can call Y. And you have two of them, so the percent of one plus the percent of the other will equal the total, which is 100%, or 1. So in other words, if I add X and Y together, I get 1. So one of them is going to be X, and the other, if I rearrange here, is going to be 1 minus X. And so those are your two individual isotopes in order to solve for their percentages. So let's go do that real quickly. So what I have is 34.969 times my percent of that isotope, which is X. And then added to that, I'll use my other isotope, 36.966, times its percentage, which is, 100 minus whatever X is, or 1 minus X. And then our overall average atomic mass is 35.453 AMUs. We'll leave the units off for the calculation. If I go through and I distribute, multiply, I get 34.969x plus 36.966 minus 36.966x is equal to my overall average, which is 35.453. If you go and solve for x, skipping a couple steps here, you end up with your x value being 0.7576. So that means that the first one that we looked at, this one up here I'm circling, is 75.76%, and then you could calculate what your Y is, the other isotope is as well. What you end up getting is that your first isotope, the X, was 75.76% of the total, and your Y isotope was, 24.24%. And so this is how you calculate what each of the isotopes are. Your lab will be set up very similarly. You guys will have a total mass of 10 pennies in a tube, and you'll try to find out how many of those pennies are of one type and how many of those pennies are of the other type, pre and post 1982 pennies, as they have different densities and amounts of copper and zinc in each of them. So anyway, what you need to do first, now that you've seen this, is go and do the pre-lab questions at the beginning. They're just a few definitions, and then you can kind of get started on the lab. We will have pictures based on your alpha letter of your last name as to which one of the tubes that you need to use, but just follow the directions. You guys will be okay. All right.